video is part 2 of the isosceles triangle theorem, and it's all about problem solving using the theorems and corollaries we learned in the last video. So picking up where we left off, example 2 has given PQ equals PR. So let's mark these two segments congruent. TR equals TS. So we have two more congruent segments. Now we need to be careful. We're not going to use the same congruency marks because we're not told that these segments are congruent to the first two segments. So which one of the following must be true? One or ones. We might have more than one that turns out to be true. ST is parallel to QP. ST, I'm going to extend this line. We want to know whether it must be parallel to QP. Well, at first glance, there's no angles marked here, so it doesn't seem like there's any way we could prove these lines parallel. But let's remember what we learned about the isosceles triangle theorem. This triangle here is an isosceles triangle. We have the two legs marked, so we can mark the two base angles congruent to each other. Now I'm also noticing that I have a pair of vertical angles here. So I'm going to mark those two angles congruent. And over here in this triangle, I have another isosceles triangle with the legs being RT and ST. So the two base angles for that isosceles triangle would be angle SRT and angle S. So I can mark that congruent as well. I can use the same congruency marking for all four of these angles because I've shown one by one that they're all congruent to each other. So now that I have some angles, I might have something to work with as far as parallel lines. These are the two lines that we're wondering whether they're parallel. So let's find a transversal that has some angles attached to it. I'm seeing this transversal, QS, and I have a pair of alternate interior angles. And we've already marked these congruent because we deduced that from the isosceles triangle theorem. So in fact, I can say that line PQ is parallel to line ST by the alternate interior angle converse. Okay, what about ST equals QP? ST, this side here, equaling QP. Well, I was careful in the beginning not to mark this segment congruent to this segment because we weren't told that. Is there any way we could deduce that? Possibly by proving these two triangles congruent. But notice that the segments that I have marked congruent are all in one triangle. There's no segment here that's congruent to a segment over here. And to prove two triangles congruent, I would need at least one segment congruent from one triangle to the other, and I don't have that here. All I have is congruent angles. So there's not going to be any way that I can prove these two triangles congruent, and hence there's no way that I can prove QP congruent to ST. So that's a no. How about angle T and angle P? Could I prove those two angles congruent? Well, I've already proved these two lines congruent, QP and ST. And I'm noticing here that PT is also a transversal for those two parallel lines. And since I've already proved them parallel, I can further deduce that alternate interior angles for these two parallel lines are congruent to each other. I'm going to put a double congruency mark here and here because we have not shown that this angle is congruent to the ones that I marked before. But we can deduce from the fact that PQ and ST are parallel that angle P and angle T are congruent. So yes, I do have that one. You try one. Given that angle S is congruent to angle T and ST is parallel to QP, which ones of these statements could I say for sure was true?